Hi to everybody. Hello. Hi to everybody. Today we are going to discuss about the next topic is Coulomb's law. You have an idea from the gravitation. There are two masses are there. Those two masses are separated by a distance of d. Then the force of attraction supposed to. This is a one talking about gravitation. This is a one body. This is another body. These two bodies are separated by a distance of d. Or you can take no issue. Then we are writing force F is directly proportional to product of the masses. Like instead of masses, now this time we are going to consider there are two charges are there. Let it be the first charge is Q1, second charge is Q2. These two charges are there. Now if I am going to talk about these two charges, the distance between these two charges is the r. This charge is at the rest, even this charge is also at the rest. Now these two are the stationary charges. See, look at here, this stationary electric charges, that is Q1 and Q2. Q are separated by a distance is r. The force of attraction or repulsion, that I will tell you the later. The force of attraction or repulsion between the stationary charges is F. So first one, directly proportional to product of charges. Directly proportional to product of charges in the sense F is directly proportional to Q1 and Q2. Let it be equation number 1. And if this is supposed to be, I am not changing the distance. I am conducting a small experiment. In that experiment, Q1 is equal to 1 coulomb, Q2 is equal to 2 coulombs. Force F is when? Okay. I am not changing the distance. This time Q1 dash is equal to 2 coulombs, Q2 dash is equal to 3 coulombs. Between these two forces is said to be F. Then what is the force between these two? I am not changing the distance between these two. I am changing only the magnitude. If I am going to changing the magnitude, first is if 1 coulomb and 2 coulombs between these two forces F. This time I am changing the magnitude. That means 2 coulomb and 3 coulomb. That time force is F dash. Without changing the distance between these two bodies. If I am going to speak about those things, F is directly proportional to Q1, Q2. So F by F dash is equal to Q1, Q2 divided by Q1 dash into Q2 dash. So we are going to get 1 means Q1 is 1, this is 2 divided by 2 into 3, that is equal to 1 by 3. New force, you are going to get F dash is equal to F by 3. Sorry. F dash is equal to 3 into F. This is the one. F dash is equal to 3 into F. This is F dash. New force because beginning Q1 Q2 value 2c. After Q1 Q2 value 6c square. That means first is 2 into 1 is equal to 2. This second one 2 into 3 is equal to 6. 2 by 6 is equal to 1 by 3. That is equal to F by F dash. Then F dash is equal to cross multiplication. F dash is equal to 3 into F. That means if magnitude of the force is increases, that is with the product of the charges is also increases. If product of the charges is decreases, force is also decreases. From this we conclude that force is directly proportional to product of the charges when the charges are at the rest. So this is the first one. Next is we are going to speak about the Coulomb's law. The other part of the Coulomb's law is nothing but the force is inversely proportional to square of the distance between the charges. That means supposed to be this is a one charge, it's a Q1, and this is another charge is Q2. The distance between these two charges is R. Now F is from this statement, F is inversely proportional to square of the separation between these two. Now from the above you can apply this one. There are two charges are there. Let it be the charges are Q1 is equal to 1 coulomb, Q2 is equal to 2 coulombs, and R is equal to 1 meter. That time the force F1 is equal to F. Now I am not changing the charges. That is again Q1 is equal to 1 coulomb, Q2 is equal to 2 coulomb, R2 is equal to, let it be this is R1, R2 is equal to 3 meters of distance. Then what is F2 value? I am not changing the Q1, Q2 values. That means product of the charges remains the same. If I change the product, that means if I change the magnitude of the charges, automatically we need to apply the first also. Now let it be this equation number 2. I am not changing. We are going to apply this equation like this. F is directly proportional to 1 by R squared. That is F1 divided by F2 is equal to R2 by R1 whole square. F1 by F2 is equal to R1 by R2 whole square. From this, first is F, second is F2, that is equal to R2 is 3 divided by 1 whole square. Now from this one, F is equal to F dash is equal to R, F2 is equal to F2 is equal to F by 9. This is the conclusion. Do you remember here? If I am changing the magnitude of the forces, automatically if product is also increases, then force between them is also increases. If I am increasing the distance between the two charges, automatically first force is F, while the second force is F by 9. That means it is going to be reducing. That is nothing but the inversely proportionality. This inversely proportional to R square. So first is distance is 1, second meter, second one is distance is 3 meter. But F by F2 is equal to R2 by R1 whole square. Then you are going to get 9 F2 is equal to the cross multiplication F divided by 9. That means if you increase the distance, force between the charges is going to be reduced. If you reducing the distance, force between the charges is going to be increased. So this is the first and second. So from the first and second, from the first, I said that force is directly proportional to product of masses. Second one, force is inversely proportional to square of the separation. From these two, F is directly proportional to Q1 Q2 by R square. That F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square, where 1 by 4 pi epsilon naught is equal to K naught. 1 by 4 pi epsilon naught is equal to K naught is called proportionality constant. So for air or vacuum, K naught is equal to 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9. The units are Newton meter square by coulomb square. This is the K value for the space or for the vacuum or the air. That is K naught is equal. Sometimes we use the space also. 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9 Newton meter square by coulomb square. That is the K naught. We are going to talk about from these two. The first one is 1 by 4 Q. F is directly proportional to Q1 Q2. F is inversely proportional to square of the separation between these two. From this, F is directly proportional to Q1 Q2 by R square. If I wish to remove this proportionality, I am introducing the proportionality constant that is called 1 by 4 pi epsilon naught. This is as usual, that is Q1 Q2 divided by R square, where 1 by 4 pi epsilon naught is equal to K naught is called proportionality constant. So here and vacuum, K naught is equal to 1 by 4 pi epsilon naught, that is equal to 9 into 10 to the power of 9 Newton meter square by coulomb square. Here the constant value, that is K naught, is depends on the medium. If medium changes, K naught is also changes. Now here epsilon naught is called the permittivity of the space. For the permittivity of the space, its value is 8.854 into 10 to the power of minus 12 coulomb square per Newton meter square. That is called the permittivity of the space. Later we will discuss about the permittivity also. As of our discussion, we discussed about the epsilon naught also. Its value is 8.854 into 10 to the power of minus 12. Now, when the force is said to be attractive force, when the force is said to be repulsive force, that concept we are going to discuss it now. As of the Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. That I am writing K naught Q1 Q2 by R square. If Q1 Q2 is greater than 0, if I say Q1 Q2 is greater than 0 in the sense Q1 is positive, even Q2 is also positive. That means you can write down, you can do one thing better. Q1 comma Q2 are like charges. Q1 Q2 are the like charges. Q1 Q2 are the like charges in the sense Q1 is positive, Q2 is also positive. Q1 is negative, Q2 is also negative. If Q1 Q2 is greater than 0, then the force is repulsive. Do you understand? If similar charges are there, like charges are there, then the force is repulsive force. Condition is Q1 Q2 is greater than 0. If Q1 Q2 is less than 0, means Q1 and Q2 are dislike charges, dissimilar charges. Dissimilar in the sense one is positive, other is negative. One is negative, other is positive. Positive into negative, less than 0. Negative into positive, less than 0. That is when Q1, Q2 less than 0, then force is attractive force. So I am going to conclude once again. According to Coulomb's law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. That 1 by 4 pi epsilon naught is nothing but a constant. That constant is nothing but the K naught into Q1 Q2 by R square. So if Q1 Q2 is greater than 0, this is possible. Either both charges are the positive or either both charges are the negative. That is like charges. Both are maybe positive, both are maybe negative. Then force is repulsive force. That means like charges or similar charges repel each other. Next, if Q1 Q2 less than 0, that means Q1 and Q2 are dissimilar charges. That means one is positive, other one is negative. Minus 2 into plus 1 is equal to minus 2, less than 0. Can you understand? This is R. minus 1 into plus 3 is equal to minus 3. It is also less than 0. Such that Q1, Q2 less than 0. If those two are less than 0, that is possible. One is negative, other one is positive. Or one is positive, other one is negative. So Q1, Q2 less than 0, that is Q1 and Q2 are dissimilar charges, then force is said to be attractive force. These two conditions are very important in solving the problems. Right? As of our discussion, there is this vacuum or air between the two charges supposed to be. This is a one charge is Q1, this is another charge is Q2. The distance between these two, this is one charge is Q1, this is another charge Q2. The distance between these two is the R. Now, when the distance between these two is filled with air or vacuum, then force F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square according to Coulomb's law. This time I am changing, this is the one, the distance between these two is the R, let it be this is Q1, this is Q2 is the another charge. But these two is fulfilled with some other material media. Some material. Now, force F dash is equal to medium changed when space epsilon. Apart from space, 1 by 4 pi epsilon Q1 Q2 divided by R square. When space is there, epsilon naught. Apart from space, epsilon only. Let it be equation number 1. This is equation number 2. Now, from 1 divided by 2, we are going to get F divided by F dash. F divided by F dash, where 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Fine. Divided by 1 by 4 pi epsilon Q1 Q2 divided by R square. These two cancel. 4 pi also cancel. This epsilon go to here, then becoming epsilon divided by epsilon naught is equal to new force, that is K. That is nothing but you can write down F divided by F dash. F divided by F dash. Epsilon by epsilon naught is called relative permittivity. Or dielectric constant epsilon naught is equal to K, where that is equal to F divided by F dash. From these two, we are going to conclude that F dash is equal to F by K. That means F dash is equal to, I am cross multiplying this one, F dash is equal to F by K. F dash is equal to F by K in the sense, if you are introducing any new medium, suppose even air is where the vacuum has a space, force is F. If you are introducing any material media, force is F dash. Force is increased or decreased, force is decreased by K times, where K is called the dielectric constant or relative permittivity. This is relative permittivity epsilon. This is equal to epsilon, where epsilon is called the relative permittivity. Now, K by epsilon naught is equal to K is nothing but relative permittivity, or epsilon is equal to F by F dash. From this, when you are introducing the material media between the two charges, the force is decreases by k times. Next is dielectric constant again. I will give the clear picture about dielectric constant. Look at it here. K is called the relative permittivity or dielectric constant. Dielectric, die means two types of polarity that I will explain in detail in the next chapter. K is also called relative permittivity and the dielectric constant. That K is equal to epsilon divided epsilon is equal to epsilon by epsilon naught, where epsilon is called the relative permittivity. Now epsilon is the medium permittivity, epsilon is the space permittivity. The ratio of medium permittivity divided by space permittivity is called the relative permittivity or the dielectric constant. Dielectric constant value for metals is infinite and for the insulators is 0. That means the meaning of these insulators is 0. The number of free electrons available in the insulator is 0. Almost no free electrons are available. If you are introducing, if they are, suppose if it is not equal to 0, for insulators not is equal to 0 in the sense, if they are not allowing any electric nature from one end of the conductor to another end of the conductor. That is the physical meaning of dielectric constant K for the K is equal to 0 for the insulators. That means there is no passage of electric nature from one point to another point of the insulator, or one end of the insulator to other end of the insulator. If I am going to talk about the conductors or the metals having the more number of free electrons. I hope so you have an idea from the D block element. All the metals are not the D block elements, but all D block elements are the metals. Metals having more atomic number, that is where IP values are very less for the metals. So that is why if you are going to speak about in the groups from top to bottom, ionization value, that is IP values are going to be reduced because atomic number is increasing. That is where nucleus interaction upon the outermost electrons will be less. So that is the thing. Actually, we are going to say existence of the d orbitals. So now, because of that reason, K value for the metals is infinite. That means it can polarize. For insulators, there is almost no free or conduction electrons. That is why there is no polarity exhibited by the insulators. That is why there is no electric effect. Then K value, that means it can't allow the electric nature from one end of the conductor to one end of the insulator to other end of the insulator. It can allow the, in case of the conductors or the metals, so it is having the more number of conduction electrons. That's why it can allow the polarity from one end and the other. That is about the thing. So this is about dielectric. This dielectric, some problems in advanced level, they may use this terminology. That terminology is dielectric constant K is also called specific inductive capacity. Dielectric constant is also called as specific inductive capacity. This is the one. Today we discussed about Coulomb's law. According to Coulomb's law, there are two charges are there. Those two charges, this is the first point I am speaking, Coulomb's law. The statement of Coulomb's law, there are two charges are in the rest position separated by distance of t. Then force between these two charges is F directly proportional to Q1, Q2 and inversely proportional to F is inversely proportional to R square. From that we conclude that F is directly proportional to Q1, Q2 by R square. We remove a proportionality, introduce the proportionality constant, that is called K naught, 1 by 4 by epsilon naught, Q1 Q2 divided by R square is the proportionality. Its value is 9 into 10 to the power of 9 into 10 to the power of 9 Newton meter square by coulomb square. After that, we discussed about the dielectric permittivity. Epsilon naught is the permittivity of the space. If you are introducing any other media, then that medium of permittivity is epsilon. Epsilon by epsilon naught is called the dielectric constant K or relative permittivity epsilon. You may get the doubt. Both are the same. Both are the same. K is nothing but dielectric constant, or also called epsilon relative permittivity, that is epsilon naught by epsilon naught. Here epsilon is called the medium permittivity, epsilon naught is called the space permittivity. The ratio of medium permittivity divided by space permittivity is called the dielectric constant or nothing but relative permittivity. Now K value for metals is infinite. For insulators is 0 because in insulators there is no almost all conduction electrons is 0. It can't allow the electric effect. In metals, most of the conduction electrons are available. That is why it allows the electric effect. So this is nothing but the advanced one. This is also called as sometimes in the problems dielectric constant or the permittivity, relative permittivity is also called as specific inductive capacity. So tomorrow we are going to discuss about the vector form of Coulomb's law and related to NEET and JEE.